Can you see my screen? Can you see my screen?
I can't see your screen, sir. I can only see your face.
Okay. Sorry, let me check again. How about now? Can you see my screen?
Sir,
What do you say?
I can see your screen now, sir.
All right, good. So, I'm trying to use the pointer so you can be able to see me clearly how I navigate. So we said in the previous lesson, we learned about uh, chemistry, and we defined chemistry as a branch of science, okay? Physical science precisely, that deals with the structure and properties of matter. Is dealing with the structure, composition, and properties of matter. Do you remember what matter is? Can you tell me what matter is?
It's anything that holds mass
Yes. And what? Anything that holds mass and what?
and takes up space.
And occupies space. That's good. So that is what matter is. Okay. So that we learned in the previous lesson. So now can you tell me the three states of matter, the three states of matter. Can you tell me? You glitching. I can't hear you.
States of matter.
Yeah. Will you like to hide your video? Please hide your video, please. I think the network there. The network is somehow. Okay, so now can you tell me the three states of matter?
Solid, liquid, and gas.
Very good. Very good. So now, um, then you just answered that. Now let me quickly put this question to you. The solids, their particles, how are they arranged? Is there space between the particles of
There's
solid?
no there's no space between the particles. They're packed up.
Very good. Impressive. So they are packed. They are packed up. How about for liquid and gas? How is the spacing between those two? Gas and liquid. Which one has more space
Gas has more space.
than liquid, right?
Yes, sir.
Good. Good. So the one I'm drawing now, is it for liquid, gas, or solid?
Solid.
Good. This one is solid. All right. Now, you will now tell me between these two, which one is liquid and which one is gas. I've drawn one. I'm drawing the third one now. So you now tell me which one is gas between them and which one is liquid. So now, is this liquid or is this liquid? So one is liquid, one is gas. So which one is liquid, which one is gas?
The one on the far right, liquid, because they're
Impressive.
closer together.
Very good. How about the one here?
Gas.
Good. Impressive. Why this one is
That one is
why this
solid.
good. This one is solid. Can you hear me clearly now? Is the audio, am I still glitching? Or is it very clear now?
It's clear now.
Okay, better. I tried another means, so I was able to, do that. All right. So now, uh, another question has been posed here, and the question says, what are the three states of matter? Okay, what are the three states? What is the basic difference between the three states of matter? The basic difference between the three states of matter. Okay, so the difference between the three states of matter is the degree of their, of the movement of the particles. So gas tends to be faster than liquid. Gas are much more faster than liquid and solid. Then liquid is a bit liquid flow. The flow of liquid can be turbulent and can also be normal, parallel. But for solid, they are closely packed, so they don't move. Okay, so that is that we disclosed those ones in our previous lesson. So today we're going to look at elements, compound, and mixture. In the periodic table, we have many elements that are present in the periodic table. Okay, there are many elements in the periodic table, about 110 and above. As at 2016, we have about 100 and 10 elements in the periodic table, and there are still space for more. So now an element is a substance that cannot be broken, down into smaller units by an ordinary chemical process. So it's not as if you can break an element. You can actually break an element, all right? But meanwhile, you can't break it down using ordinary chemical process, but you have to use processes that are special before you would be able to break down an element. So the process has to be very special, okay? So ordinary chemical process will not in any way break down an element. So which is why this element is a substance that cannot be broken down into smaller units by an ordinary chemical process. Are we together? So Adedayo, if you are asked what an element is, what would you say?
Is uh a substance that won't be broken into smaller parts.
By ordinary. You know, that are ordinary in science. Why some reactions are not ordinary? They are nuclear reactions. Okay, like the bombardment of elements using neutron. When there is atomic bomb explosion, atomic bomb could be made using uranium. Uranium is an element in the periodic table, so they use it in making atomic bomb. So it's an element. When it explodes, when it detonates, it's going to split and it gives another element that is also radioactive. So now that uranium has been broken down. Now that is special reaction. That is not an ordinary reaction. Okay, that is not an ordinary reaction. It's a special reaction. So that those reactions can break elements down as uranium has been broken down by a series of, explosions. But meanwhile, ordinary chemical process, as we have it here, will not break an element. So that's why we define an element as a substance that cannot be broken down into smaller unit by an ordinary chemical process. Is that clear? I can't hear you. You're glitching. Is that clear?
Yes, sir.
Good. Can you just tell me briefly what you understood by that? Can you tell me your understanding about what I just explained about an element?
Is a substance that can't be broken into small pieces by chemical processes.
Those chemical processes, what kind of chemical process can break an element? Is there a special type of process that can break an element? Yes or yes? I said nuclear process is not ordinary. Okay, nuclear reaction. Do you get that now?
Sir?
Nuclear reaction is a special reaction. All right,
Yes, sir.
good. So there are around 100 naturally occurring elements which can be seen in the periodic table. So when you check the periodic table, you see elements in there. You see elements. So there are about, 100 naturally occurring elements which can be seen in the periodic table. Okay, so elements consist of atoms that all have the same number of protons. Okay, now before I explain further, so I would like you to write down this in your booklet. You can write this down in your booklet. All right. Can you hear me, Adedayo?
Yes, sir.
All right. Are you writing now?
Yes, sir.
All right, good. Well done.
Please scroll down, please.
All right.
Down, sir. Can you scroll down, sir? Sir, can I go to the toilet, please?
All right.
So I'm back.
All right. Hold on. A moment, please.